As I said, we have scalars and vectors. Vectors have directions and magnitude. Scalars only just values, magnitude. So when you have a vector, let's draw a vector. So let me draw my x and y axes first. New pen. Come on. Doesn't want to work. I have other ones. So there's the x and y axes. Let's say I have a vector has a value of 50 units and has an angle of, this is the angle of 30 degrees. How would I graph that? 50 angle 30. I'm going to take my protractor, lay that across. Notice the protractor you have, there's a few different ones I passed around. First find where the 30 degree, line up the 0 with the x-axis, the 90 with the y-axis. Might not be exactly perfect there. You might be a hair off. That's okay. And the 30 degrees is in this direction. See where the 30? Can you see it on? So I put a little mark where the 30 degree is. It's in that direction. So my vector is going to be 50 units long at angle 30. Well, I'm not going to use 50 inches or 50 centimeters. I need a huge paper. So I might use a scale here. In my scale, I might use, I don't know, 1 centimeter equals 5. So if I have a vector of 50, how many centimeters that vector will have to be? How long? 10 centimeters, right? So here we go. This is 10. Oh. So this is that vector. That is the 50 angle 30 degrees. Now this vector has two components. One in the x direction, one in the y direction. This is the component in the y direction. And this is the component in the x direction. So this is known as the y component. And this is the x component. And can we find the values from the picture here? Sure. What's the y component? Let's measure the length of that. That looks like 5 centimeters on mine. Does yours look like 5 centimeters? So the scale is what? 5. So it's going to be 5 times the scale, which is 5, and that will be 25 units. And the x component here, let's measure that. I got just a hair over 8.5, like 8.6. My scale is 5 units. What's 8.6 times 5? It's 43 units. Let's see if actually these are correct. This is how we do them graphically. When you have a vector, we'll give it the value r and theta. I'm just going to use it in general there. That's a vector. We can break it down to x component and to y component. to get the x component, it's always going to be r cosine theta, and the y component is always going to be what? R sine theta. Why? If you remember your trig, this is r, this is theta here. This side is the adjacent. Remember, what's cosine theta? From geometry, the adjacent over the hypotenuse. What's the adjacent? The adjacent is the x value, and the hypotenuse, that's r. So that's why when you solve it for x, x is always equal to r cosine theta. Again, what do we know about the sine? The sine of theta is what? Sine is opposite over the hypotenuse. What's the opposite? This is theta. What's the opposite to that? Y. And what's the hypotenuse? R, which means y equals r sine of theta. So that's the reason why we use the x component always r cosine and the y component always r sine. Let's see if we did this correctly. My r here is 50, and theta was what? 30 degrees. Make sure you calculate in degree mode. So put your calculator in degree mode. Here we go. Mode. First thing first. I gotta make sure I'm in the right mode. I am in degree mode on my calculator. So 50 times the cosine of 30 degrees. And it says 43.3. What did we get? 43. The y value is going to be what? 50 times the sine of 30 degrees. 50 sine of 30, and that's 25. And we got what? 25. So we did that correctly. So if you are given r and theta, you can find the x and the y value. The x component, it's r cosine theta. The y component, r sine theta. You can also work it backward. If you know x and y, you can find r and theta. Next example. Let me draw the x-axis and the y-axis anywhere here. Let's say I know the x value and the y value. Let's say the x value, somebody pick a number. We'll use a scale. 1 centimeter equals, I don't know, 10. So how many centimeters for x you want to use? Pick a number between 0 and 10. 4? Let's make the x value 4. This is the x component. And let's pick a value for y. Pick a number again between 0 and 10 for y. 9? Where's the 9? Here is the 9. This is the y component. This is 4 here. This is the 9. Can we get what r and theta is? R will be this one. Which looks like a little bit less than 10. 9.8 maybe. So with my scale being 10, R is probably what? 9.8 times the 10, which is what? 98. And how do we figure what theta is, the angle? We take our protractor and lay it over that and read that value. And I'm getting roughly what? What do you got there? 66 degrees maybe? I'm using a thick marker, so the thickness of this almost 2 degrees. So somewhere around 65 degrees. Let's see what the numbers mathematically should be. So if you know the x component and the y component, if you know these two, so we know these, then to get r, it's always going to be the square root. Pythagorean's theorem. Remember Pythagorean's theorem? X squared plus y squared. So in this example, it will be the square root of 90 plus 40, which is the square root of 130. Did I read this wrong here? Is that 9? 9, 4, oh 9, 4, I'm sorry. 9 square, not 90, 9 square. What's 9? It's not 99 square, which is what? 81, right? So this will be 9 squared plus 4 squared. What's 9 squared? 81 plus 16, which is what? 97? Take the square root of 97. Which is 9.85, and I'm using a scale of what? What's my scale here? 10? So what are we getting? 98.5. And when we do it mathematically or graphically, we get 98. And what about theta here? Mathematically, when you have this, we know it's the inverse tangent of the y over x. So that'll be the inverse tangent, y, which is 9, x is 4. So take your calculator, take the inverse tangent of 9 over 4, second tangent, parentheses, make sure you do parentheses, 9 divided by 4, close parentheses. 66 degrees. And that's what we got right there. So the stuff does actually work. So to make that a rule here, if you are given r and theta, then you can find the x component by finding that as r cosine theta, and the y component r sine theta. That's how we do it. As long as theta is measured with respect to the x-axis. If you are given the x/y component, you can find r and you can find theta. R is going to be what? The square root of x squared plus y squared. And theta will be the inverse tangent of y over x. The only time you have to make an adjustment to that, I'm going to put an asterisk for this one right here. Add 180 degrees if you are in the second or third quadrant. Y. Let's see y. Especially that one. Why we have to add 180 degrees if we are in the second or third quadrant? So let's draw a vector in the second quadrant. And let's make it, I don't know, 8 units in the x direction. That'll be a negative 8 because you're going to the left. 8 units. That's negative 8. And let's say the y value happens to be 6. This is the x component. This is the y component. And that's a 6, positive. It's going upward. So y is positive 6, x is negative 8. Can we find theta and r? What is r from this picture? It looks like 10. So graphically, r is 10. I just connected and measured it. It says 10 centimeters. Theta here, let's read what the value is. Well, when we measure theta, we always like to measure theta from the positive x-axis. So when you measure it from this line, it reads what? 143 degrees? So this value is 143 degrees, which means if you just want to give that value the little value, the little value is going to be what, 36 degrees? Maybe 144 actually. That's a 36 degree actually from this end. Well, we always ask you to give us the angle with respect. This is my reference. So your angle has to be measured with respect to this line. So you're going to say your answer is 10 angle 144 degrees. Let's see if we can do the math here. R is supposed to be the square root of x value squared plus y value squared. The x value is negative 8. Square it. The y value is 6. Square it. 64 plus 36. The square root of 100, which is what? 10. Got it. I got r equals 10. But what about theta? Well, we say theta is the inverse tangent of the y value over x. The y is what? 6. X is negative 8. My answer should be 144. But if I put this on my calculator, watch what's going to happen. It's going to give me negative 36. Second tangent of parentheses 6 divided by negative 8. It says negative 36 or negative 37 degrees. Negative. It puts me down this quadrant. The reason the calculator divides these two numbers, it doesn't know where the minus sign came from. If the minus was on the top and the plus on the bottom, they'll be right. You'll be in this quadrant. Notice if x was positive, y was negative, you will be in this quadrant. So the calculator doesn't really know that. It just says that number is negative, but it doesn't know it's negative because the x is the negative value or the y is the negative value. So always assumes it's in this quadrant. That's why if you're in this quadrant or this quadrant, you always want to add 180 degrees. Because when you have two negative numbers here, you divide them. What's a negative over negative? Positive. It thinks you're in that quadrant. So I got to add the 180 to this answer. So that's the reason why we add the 180 when we're in these two quadrants. So what's plus 180? And that angle is 143 and some change. How do we add vectors? We're going to do them graphically. We're going to do them mathematically too. So let's say two vectors. We're going to add them. Let's put the x and the y-axis toward the left side of your paper, because I'm going to make two stories out of it. The x here to the left and the y toward the bottom. Gives me more space there. And let's say you decide you're going to go walking here. And you walked let's pick an angle. What direction you want to walk first? $40 degrees. Let's say a 40-degree angle. Here we go. You walk 10 miles. We'll use 10 centimeters. 1 mile is 1 centimeter. You walk 10 miles in that direction at 40 degree. So this angle was 40, and you walk 10 miles. And when you get to this point, you decide, you know what? I'm not tired. Let me walk another direction. So let me make another set of x and y axes here. You walked, I don't know, how many miles do you want to walk in again? Another 10? What direction? You can use more than 90 degrees too. You can do negative if you want to. Backward, I can flip this upside down. So you decide which way you want to walk. 140 of 10 miles again. So you walked another 10 miles of direction of 140 in that direction. So let's do 10 miles, that's 10 centimeters. Right there. That's 10, and this is hopefully the 140. And now he said, you know what? You slipped there, broke your leg, and now we're going to send you some rescue people, helicopter to pick you up. We need to let them know where are you, how far from this point. So the result is really this one. That's the result, where you are. And I'm measuring that distance, that looks to me about 13. And what's the angle we have to send the helicopter looking for you? What is the result? To me it looks like what? Maybe 92 degrees? So that angle here is 92 degree heading, or 2 degrees to the left of the north. But if you measure the angle from this axis, this is my reference here, I'm going to tell them to go 92 degrees in reference to this and go about 13 miles. This should find you there. That's how we add vectors graphically. How do we do them mathematically? We're going to take the two steps that we just did there, put them together, and find where you are. So, adding vectors mathematically. I'm going to write the procedure for that. Adding vectors mathematically using Trig. Step number 1, write the vectors with respect to the positive x-axis. When I say with respect, I'm talking about the angle. That's the first step. Write the vectors with respect to the positive x-axis. Step number 2, find the x/y component of each vector. And again, to find the x component, we use r cosine theta. And to find the y component, we use r sine theta. Step number 3, add the x and y components to get the result in the x and the result in y. So when you add all the x component, you're going to get a number that's called r sub x, the result. When you add all the y values, you're going to get one number, and that's the result in the y direction. Now step number 4, find r and theta. And r is going to be found by taking the square root of the x value squared plus the y value squared. And theta is going to be the inverse tangent of the y value over the x value. Add 180 if in quadrant 2 or 3. Quadrant 2 or 3. So these are the steps I'm going to use to add vectors mathematically.
Mathematically, how do you know what quadrant you're in? Like if you didn't graph it out, just doing it mathematically.
The angle will tell you. That's why you write the angle with respect to the positive x-axis. It takes care of that. When you get the result at the end, you'll know which quadrant, the net result, because we're going to graph it. You'll see when I do an example in a minute there, Adam. That's what's going to happen. So somebody, let's take the two vectors we just did. What were they? It was 10 angle 40 and 10 angle 140, right? So let's add them. So here's the question. Find the sum or the result of 10 angle 40 plus the other one was 10 angle 140. What I'm going to do actually with these, I'm going to make a table. What I like about the table, it reminds me to do all the pieces I need to do. The first column, I'm going to write the vectors in it. The second column is going to have the x component, which is r cosine theta. Just a reminder, that's how you find it. The y component. And to find the y component, we use y equals r sine theta. You're going to see me make that table all the time when I'm adding vectors. So let's look at the first vector. What was the first vector? 10 angle what? 40. The x value for that is going to be what? 10 cosine 40. And the y value is going to be what? 10 sine of 40. I'm going to round my answer to a whole number just to make my life easy there. 10 cosine, or maybe one decimal place. One decimal place is what? This is 7.6. Or 7.7. One decimal place, 7.66. So that's 7.7. The y value is 10, the sine of 40. I got 6.4. Is that what you got? Make sure you're getting the same numbers. I do have a habit of making mistakes with the calculator. The second vector was 10 angle 140. We know x has to be negative. You're in the second quadrant. The math is going to tell me that. 10 cosine 140 negative 7.7 and the y value is 10 sine 140 6.4. So I wrote the vectors. I found the x and the y component. What is r sub x? Or the result, I should say here. R sub x is going to be 0. And r sub y is going to be what? 12.8. So the question came up, how do you know which quadrant? In this case, notice x is really 0 and y is almost 13. If x is 0, that means you don't move in the x direction. You go 13, it's in the y direction. So I'm not going to graph it to scale, but your vector is going to be going that way. Yes?
How did you calculate r sub x and r sub y?
Huh?
How did you calculate r sub x?
R sine theta. Oh, r sub x?
Yeah.
You add these two numbers. R sub y, you add these two numbers. So that's the result in the y direction for all the vectors together. That's the result in the x direction. I don't even have to do the math because I know this is 12.8, but r is going to be now, that's the next step, is the square root of x squared and y squared, the square root of 0 squared plus 12.8 squared. You do the math, that's 12.8. And theta is the inverse tangent of what? Y over x. Well, we got a problem here, right? Can you divide by 0? Can't. So you have to look at your picture now and see, my vector has no value in the x direction. You're not going the x direction. You're only going straight up. So how big is this angle? 90 degrees. That's why we graph the result at the end, to see which quadrant we are in. So it's 13 angle 90. When I did it graphically, I said 13 angle what? 92? Is that what I said before? And as I said, my pen is about 2 degrees to 3 degrees, the thickness of it. Yeah, I got 1392. The value of 13, the angle 92. We get the value of 13, the angle is 90. I was very close to it. Let's try another one. I said write the vectors first, because the reason I said write the vectors, because a lot of times actually we try to deceive you there. What does that mean? Let's see if I can get this one. Let's say we have these three vectors. I'm just going to draw them here, not to scale. I'm going to do them mathematically. An example, here we go. This is a deer. A lion just killed a deer. Poor lion. Poor deer. We got one of the lines pulling in that direction on it. The force is 50 and the angle is, let's say it's 35 degrees. We got one pulling in this direction, a bigger lion. The value is 70. And we'll say this angle. I'm giving you that angle intentionally. This angle was 20-degree angle. And I got a third line, medium size one, that's pulling in this direction with a value of 60, and this angle is 10 degrees. And if the deer actually doesn't come apart into pieces, they're all going to move. So what's the net result of all these forces acting on it? What is one force that's equivalent to the sum of these three? We can do this mathematically, we can do it graphically. Let's try it graphically first, then we'll do it mathematically. So there's our story. Let's graph this to scale and see if we can get the result, or close enough. I'm going to put the x-axis down the bottom. The first vector is 50 angle 35. Let me find where the 35 is. The 35 is in this direction. I'm going to use a scale 1 centimeter equals, I don't know. I can do probably 5. Hopefully I have enough space to fit there. 1 centimeter equals 5. So the first one is 50, that means 10 centimeters long. That's the first one. That's 10, the length of it, 10. And this angle is 35. Now let's put x and y axes again here, because I'm going to add the other vector to it. And the other one's going to be 70 at angle 20 from the other end. Notice these protractors, you can read them both ways. 20 from this end is right there, which is 160 from the other end. You see the 20 there? 20 in that direction. And how long this vector is going to be? 70 divided by 5, is that 14? Because the scale is 5. That's the 14 here. This is the 20 degree right here. I'm right here now. Let's put x and y axes here. And let's do the third one. The third one is 60, which means 12 centimeters long. Let me flip my protractor. And that's going to be what? 10 degrees from this edge, which means 80 in that direction. 10 degrees down. That's 10, 20, 30, each one is 10. And this will be what? How many units? 12 units long. And my result, actually, if this was free to move, it will move in this direction. That's the result. It looks like I got roughly, what, 7.5? if you want to measure the angle from the positive x-axis, you go all the way to here is 180. And what's that angle? Is that almost 9 degrees? From this edge is 9 degrees. From here is about 9. So if you measure it from here, that's 180 plus 9 is 189 degrees. So my result is 7.5, but the scale is 5. $7.5 times the 5, which is what? 37.5. And the angle theta, that's R. And theta equals 189 degrees. I just measured that. So if I did this correctly, graphically there's my answer. Now I'm not really 100% sure I'm on the money there, so I tend to do these problems using math. So let's use Trig and see if the result actually is the same. So here is my table. On the top is going to list the vectors. So these are the vectors here. I'm going to write the vectors. I'm going to write the x component for each one. Which is equal to what? R times what? Cosine theta. And the y component y equals R sine theta. Let me write my vectors. Let me put it back, the picture back here. We'll call this vector A. We'll call this one B. We'll call this one C. So how do we write vector A? That's what? 50 angle what? 35? So the x value for that is going to be 50 cosine 35, and the y value is going to be what? 50 sine of the 35. Cosine 35, 40.957, how about a 41? The y value, 50 sine of 35, 28.7. Let's get vector 2 now, or B. Wow. What's vector B? How would you write that? 70 angle what?
20.
Try again.
The bigger one.
160, very good. I have good ears. Because you always got to measure the angle from here. Always. That's your reference. Because that will take care of the plus and the minus for you. If you do it that way. Otherwise, you got to do the plus and the minus. That's x value will be what? 70 cosine 160. 70, the y value. 70 sine 160. Cosine 160, negative 65.8. Sine 160, 23.9. We got one more vectors to deal with. Let's look at vector 3, or C here. What's that vector? The value is 60. What's the angle? What is it? 260, let's see. You might be right. From here to there is 180. Up to here is 270. But we're not going all the way to here. Back 10, it is 260. By the way, you could use a negative what? 100. That'll be fine. Because that's a negative 90 plus 10, that's a negative 100. Or the same as plus 260. So again, you have to measure that angle all the way here. So let's find the x value and the y value. X is going to be 60 cosine 260. The y value 60 sine 260. 60 cosine 260, negative 10.4. The y value 60 sine 260 is a negative 59.1. My calculator is missing a strip right across there on one of the numbers. Now I'm done breaking each vector into x and y value. We said we need to add and find the result. So this is the result. The result in the x direction, the result in the y direction. In the x direction, we add all three numbers. This, plus this, plus this. Let's add them. 41 minus 65.8 minus 10.4. When you add them, that's a negative 35.2. The result in the y direction, we add these three numbers. Negative what? 6.5. Now just quickly, if I was to graph them just to see which quadrant I'm in. What do we know? We know x is negative, right? What else do we know? Y is negative. So which quadrant are you in? We are in quadrant what? 3. You have to add 180 degrees to your answer, to theta. So what is r equal to? It is the square root of rx squared plus ry squared, the square root of negative 35.2 squared plus negative 6.5 squared. Make sure when you put these negative numbers, put them in parentheses. Otherwise, your calc will give you a negative answer. That's the square root of 1281.3, which if we take the square root of that, 35.8. And theta will be the inverse tangent of the y value over the x value. The inverse tangent of y. What is y? Negative 6.5, negative 35.2. You are in the third quadrant. Make sure you add 180 degrees to your answer. Second tangent, parentheses, $190.5. So the result is actually 35.8. The angle 190.5. I have no idea. I forgot what we came up with the answers. Let me take a peek. No clue. I got 37.5, 35.8, not that far from it. I got 189. This is what? 190. That's the correct answer. The graph, we're all human. We make mistakes. We're off by a degree or two. We didn't line up perfectly, but this one gives you the exact answer.
I'm so confused how you know if you, let's say you didn't graph it at all and you were just doing it mathematically, how would you know it's in that order?
Well, x is negative, y is negative.
Oh, okay, yeah.
Right?
Okay.
So even you don't have to graph this, because once you know x is negative, y is negative, that tells you in the third quadrant. You have to go to the left and down. Yeah. Any other questions? Where this actually comes in handy, I can tell you, I told you last class I fly single engine plane. If I'm in my plane and I don't pay attention to the weather, I go, you know what, let's go north. I get in the plane and the wind, let's say I point the plane north, I'm going to go here to visit a friend of mine. There we go. I'm going 130 miles per hour and I'm pointing the plane north. But what do you know that day? It's windy. And let's say the direction going from east to west. I can even give you an angle even. Let's say the wind's blowing this direction. That's the wind. I'll give you speed and value in a minute there. What's going to happen to my plane? So the wind is blowing constantly in that direction. Do you know what's going to happen to that plane? I'm pointing north. It's still going to point north, but this is what's going to happen to it. It's going to drift. The plane is actually going to travel in that direction. I'm going to miss my target. I'm pointing north, just like if you take your canoe, your boat, and the current is moving this way and you're going across that river. You're not really going across that river, you're being drifted. And that's what's going to happen to that. So before I get in the plane, I have to know which way the wind is blowing. If I know the wind is going that direction, I'm going to fly in that direction, let the wind push me that way. That's what I have to do. I need to know by how many degrees. I need to calculate the wind is going to push me in this direction by how many degrees and adjust my flight by that much so I can land right there. I can end up being where I need to go. So let's see what will happen to my plane. Let's say my plane was pointing here, speed of 130 miles per hour in a direction. I'm heading the plane in direction of what? 90 degrees? That's north. This is the plane. My wind here, unfortunately, or sometimes the wind is not bad, the wind is blowing in this direction. What's that angle roughly? Where's my protractor? It looks like that angle is what? Maybe somewhere around 120, 130, you know? It's changing there. But in that direction, let's say about 120, 130 degree. So the wind is 30 miles per hour, gusty wind, at 140 degree. Again, if you want to see what's going to happen to the plane, if I don't make any adjustment, if I use a scale 10 to 1, or 1 centimeter equals 10 miles per hour, I point the plane in this direction at 13. This is 13 centimeters long. I point the plane that direction. The wind pushes me 140 degrees. Where's 140? The wind pushes me in that direction. So right here, 140 is in that direction, from the top of that. So the wind is going to come and push me at 3 centimeters in that direction. It's going to push me in that direction. So actually my flight, my path is going to look like this. I picked up some speed. My plane is going more than 150 miles per hour now. That's about 150. I can see that's 15 centimeters. So this is 15, and that's the direction I'm going to be flying. Almost at, what is it, 99? I'm going to end up right there. Instead of going to Florida, I landed in Cuba now. Missed it. Especially when the distance is really too far. You keep going this direction. Next thing, that gap gets bigger and bigger. You missed it by 30, 40 miles, that airport. So my speed, that's 15, the scale is 10. Actually, I'm going 150 miles per hour speed because the wind is behind me. It's pushing me forward. That's why when you go to Florida, sometimes it takes you 2.5 hours. To come back, it takes you 3 hours. It's the same distance. What happened? Headwind, tailwind. You get the wind pushing from behind. If you were coming back from here to us, that wind will be facing you, slowing you down. You're not going to be going 130. You'll be going 120 miles per hour or 115 miles per hour. Let's see what the math says actually. Let's look at the math with it. I have two vectors here. Again, I need to find the x component for each one. And keep writing these equations down. You'll be surprised how quickly you memorize them by writing them down. Here's my two vectors. What were they? The first one is the plane, which is what? 130. What was the angle? 90 degrees. And the wind was what? 30. And what angle? Was it 140? These are the two vectors. 140. So the x value is going to be 130 cosine 90, and if you do the math, that's a 0. The y value is going to be 130 sine 90 degrees, which is what? 130. This one is going to be 30 cosine 140. Cosine 140, that's equal to 23, negative 23 degrees. And the y value is going to be 30 sine 140 19.3. Now let's add them. The result in the x direction is negative. The result in the y direction is what? Positive what? 159.3? 149, right? 149.3, not 59. Notice I can tell you which quadrant I'm in without a graph in it. X is negative, y is positive. Which quadrant? Quadrant 2. I have to add 180 degrees to it, to theta. I know that. I don't have to graph it. Can I give the speed of the plane the result? Rx squared plus ry squared. And that's the square root of 22,819.5, and this will give me an answer of 151 miles per hour. That's the speed I was going. My direction theta now, it's the inverse tangent of the y value over the x value. And since I'm in quadrant 2, I have to add 180 degrees to it. Second tangent, 149.3 divided by negative 23. Get an answer, add to it 180, and it says 98.75, 99 degrees. And when we did the math, it says I'm going to be going 150 miles per hour. I mean the graph. What angle? 99 degrees. The math says I'm going to be going 151 miles per hour at 99 degrees. The stuff actually works.